Hello and welcome back to the Reframework training. Now that we've explored the initialization state, let's move on to the getTransactionData state. In this video, we'll learn about the workflows, arguments, and variables used in this state. Additionally, we'll also cover the stop mechanism that the template provides. Okay, getTransactionData. This state retrieves one by one the transaction items containing the data to be processed. In this project, this is where the robot retrieves the queue items containing the cash-in, on-us check, and not-on-us check values. So, what is a transaction? We define a transaction as the repetitive part of our process. It represents the minimum atomic amount of data and the necessary steps required to process the data to fulfill a section of a business process. A typical example would be a process that reads a single email from a mailbox and extracts data from it. We call the data atomic because once it's processed, the assumption is that, going forward, we no longer need it with the business process. In the reframework, the transactions are numbered. The value is stored in the transaction number variable and it's incremented with each iteration. The transaction number variable is initialized with the value 1. The next important variable is transaction item. By default, it's of the type queue item, but the type can be changed if a different one is needed. For example, data row or mail message. In our case, we do need it as a queue item as we've uploaded the transactions from the Excel file to a queue in Orchestrator. When Orchestrator queues are used, the transaction data retrieval is handled by the getTransactionItem activity included by default. In this case, it's not necessary to make any modifications to the getTransactionData.xaml workflow. When the robot gets a queue item from Orchestrator, the status of the item changes to in progress, and it doesn't get updated until we set it to success or failed by using a setTransactionStatus activity after the item is processed. This is why, if we want to stop a process elegantly, we should do it after finishing processing the current item or just before getting a new queue item. So, the first thing that we do in the getTransactionData state is check if a stop signal was sent from Orchestrator. The shouldStop activity gives us the option to soft stop our process execution before starting a new transaction. If the stop command is received, the automation transitions to the end process state. If no stop command is detected, we invoke the getTransactionData workflow file. Alright, let's have a look at the arguments used in this workflow. We have the following two in arguments, transaction number and the config dictionary. We also have a few out arguments, the most important being transaction item. The others, transaction field 1, transaction field 2, and transaction ID are used for logging purposes, as we'll see in one of our next videos. Transaction data can be used as an alternative to store the collection of transaction items when Orchestrator queues are not used. As seen here, by default, the type is set to data table. Note that we're not using this argument in the current process. Let's open the workflow file. Now, after the log message activity, which activity would you expect to be executed first? Indeed, the first activity after the log message is getTransactionItem, which outputs the queue item from the queue specified in the config file. The getTransactionItem activity might fail, for example, with a service unavailable exception. To handle such exceptions, we've placed the getTransactionItem activity inside a retry scope and a try-catch activity. Here, the value for the number of retries is obtained from the constant retry number getTransactionItem in the config file. This value specifies how many times the getTransactionItem activity should be retried in case of an exception, and it must be an integer that is greater than or equal to 1. We can also update the number of retries by updating the parameter values in the constant sheet. In the catches block, we log the exception as a warning and then use a rethrow activity to go out to the retry scope. Remember earlier how we mentioned 3 out arguments that are used for logging purposes? Here is where we assign values to them. Let's find out more about them. The first one, transaction ID, should be unique for each transaction. By default, it's set to the current system timestamp. The second and third log fields will be used to log information about the process transaction, transaction field 1 and transaction field 2. In our case, we set the first one to the concatenation of 3 values retrieved from the queue item, cash in, on us check, and not on us check. For another example, if transaction items are invoices, then out transaction ID can be the invoice number, out transaction field 1 can be the invoice date, and out transaction field 2 can be the invoice amount. Now, at some point during process execution, all transactions will have been retrieved and processed, and the process needs to stop as no more transactions are available. This occurs when transaction item becomes nothing or null. When using an orchestrator queue, that happens by default when there are no more new items to be sent. If we change the type of transaction item argument, we need to assign it to nothing when there are no more transactions to be processed. We'll build an example of that in a future tutorial. Alright, now take a moment and pause the video to catch up with all of this information before going back to the main workflow. From this state, as seen here in the main workflow, we have 2 possibilities. One is that all of the transactions are processed and no more data is available. In this case, the process goes to the end process state and stops. The other is that a new transaction item is retrieved, so the robot executes the process transaction state next. With this, we conclude our overview of the getTransactionData state. Here are a few things to check after having gone through this demo. Can you explain what a transaction is? What role does the getTransactionData state play in the framework? Why and how do we use the stop mechanism? What workflows do we invoke in this state? What arguments and variables do we use? How can we change the number of retries for the getTransactionItem activity? In the next video, we'll dive into the process transaction and end process states. Thank you for watching and see you soon.